Hello, in lesson 5.1, similar figures, you'll learn to use proportions to solve equations and find segment lengths. Now, polygons that have the exact same angles, but are different size, are called proportional. Those things are similar polygons that are proportional. Now, polygons are similar again if they fall again into two categories. They have proportional angles or same congruent angles, and the second one is that they have proportional sides. So in order for two polygons to be similar, they have to have the same angles, congruent angles, but the sides have to be proportional. All the sides have to be proportional to each other. The corresponding sides have to be proportional. So I should be a little bit more specific here and indicate that there has to be proportional corresponding sides. So if we're looking at a rectangle, the length again of two rectangles, that all the angles are the same, the length again has to be proportional to the length of the smaller rectangle, and the width has to be proportional to the width of the smaller rectangle. Now this ratio that corresponds to the sides, this is called the scale factor. This is indicating how much bigger or smaller one polygon is to the other. And if polygons are similar, then their perimeter are also proportional. So for example, right here, let's discuss scale factor and what that means. The scale factor is the ratio of one triangle to the other one. So like right here, if we want to identify the scale factor from triangle DEF to triangle ABC, so from here to there, we want to look at the corresponding sides. Well, just like congruent figures, similar figures again are indicated by the name of the two objects. So like right here, if triangle DEF is similar to triangle ABC, that means that the angles D and A are congruent, angle E and C are congruent, and angle F and C are congruent. E and B are congruent, and F and C are congruent. Relating that, the segment DE, this one here, is going to be proportional, and it corresponds to the side length of AB. So to figure out the scale factor from this value of DE to AB, we're simply going to divide 12 over 8. The side length of DE to the side length of AB, which reduces, if we divide by 4, reduces to 3 over 2. So the ratio of this thing is going to be 3 to 2 from the triangle DEF to the triangle ABC. Now, what is the ratio of the perimeter? Well, the ratio of the perimeter is the exact same thing. And like I mentioned, a valid similarity statement must match corresponding angles and sides. So here, a similarity statement for this triangle, well, obviously the one we have here, is that triangle DEF is similar to triangle ABC. Or if I start with a different angle and start with angle F, then to D, and then to E, then I would have to again look at the corresponding angles, which F corresponds to C, D corresponds to B, and A, sorry, wrong one. D corresponds to A, and the last one, E corresponds to B. Again, looking at this, D corresponds to A, B corresponds to E, and F corresponds to C. So if I rearrange them in that order, I have to again put these letters in that exact same order by their corresponding angles. So let's now look at similarity statement. So here we have again this similarity statement indicating that this triangle here on the left is similar to this triangle here on the right. So because of this similarity statement, we know two things. The first thing is that the corresponding angles are going to be the same. So J, let me use blue. J, angle J right here, that corresponds to angle P because of the similarity statement. Angle K corresponds to angle M. Let me color that in red. And in green, angle L corresponds to N. So what that means is that because these are similar figures, those corresponding angles are going to be congruent. So angle J, the measurement of angle J, is equal to the measurement of angle P. The measurement of angle K is equal to the measurement of angle M. And the measurement of angle L is equal to the measurement of angle N. And because of that, this segment from JK is proportional to this segment here. So those are corresponding sides. And this side here, not angle, but side, I'm meaning to say side, this side here from K to L corresponds to the side from M to N. And lastly, this side from J to L, from point J to point L, corresponds from point M to point L, from that vertex from point. Oh, I did this wrong. Hold on. I'm going a little bit too quick here. I messed up on this one. This one should be the wrong. Oh, this one's right. But this one right here, I did the wrong one. I'm going from J to K, which in blue should be P to M. I looked at the wrong side. M is this one right here. So let me fix that. Okay. And this one, oops, wrong color. This one corresponds to that side right there. So that's the second thing that we know. And because these are similar, that means that there's a proportional relationship between the sides. So if I get the side from J to K and I divide it by its corresponding side from P to M, that's going to be equal to dividing again the corresponding sides of KL and MN and dividing that by the corresponding side JL by PN, which is what we use in order to figure out missing sides between two similar figures. Which is again what happens when we look at maps and we're trying to figure out the length again of the actual distance between two places on a map. We use a scale factor and identify the length again, the actual distance between two objects, again looking at that scale factor. And maps again, I know nowadays we just simply use Google or Google Travel and we can identify the distance between two places. But before, a long time ago, we had to actually get a map, look at the scale factor there, and use the proportion to figure out the distance between those between two places. So like in this example, with the similarity statement, using the similarity statement, I can figure out the value of x, again, find the value of x by looking at the proportional sides, or the corresponding sides, and setting up a proportion. So like right here, because of the similarity statement, I know that the side DE corresponds to HJ. So from D to E, that corresponds to the distance from H to J. The segment EF, the side E to F, corresponds to JG. And the side DF corresponds to HG, just simply by looking at the similarity statement, which means that I can set up a proportion. So if I get the corresponding side of 9 and divided by the 9 and divided by its corresponding side of 15, that's going to equal to getting 14 and dividing it by its corresponding side of y, and 12 and dividing it by its corresponding side of x. And because we're solving for x and we're only looking for the value of x, that means that these two things are also equal to each other. Since all three things are equal to each other, I can set up a proportion, an equation, where I can just simply set any two values that I want equal to each other. So here I can set up 9 over 15 and equal it to 12 over x. And the way that we solve this is by cross multiplying. Cross multiplying and dividing. So right here, we'll simply multiply the 15 and the 12 and then have it divided by 9. So this is the shortcut way of doing it. The long way and the algebraic way of showing this is that we cross multiply here. So this is going to become 9x. And multiplying 15 times 30, 15 times 12, that's equal to 180. And then dividing the 180 by 9, as like I told you we were going to do, that's going to end up giving us that the value of x is equal to 20. So x is equal to 20. But when you set up a proportion, you're going to notice that you're going to multiply two numbers, and that other number that gets multiplied with a variable ends up being your divisor. You end up dividing this total right here by this number 9. So this is going to be the solution to this problem here. So this is going to be the value for x in this in between these two similar triangles. So let's look at another example. Again, because of this similarity statement, we know that these two triangles are similar and that the corresponding sides are going to be the following. AG, so from point A to point G, that corresponds to KX. So K to X, that's this side right there. GM corresponds to XD. So GM corresponds to XD. And then obviously what's left over is AM, that corresponds to KD. So AM, KD right there. So with that, we can get the corresponding sides, which in this case is only looking at these two values right there. And this is not going to be helpful because we don't know anything about that orange side, and set up a proportion. So if I get to the side of 32 and divide it by its corresponding side, which is x plus 3, that will equal to dividing 36 by its corresponding side of x plus 6. And again, notice the direction I move. I move from left to right, from triangle AGM to triangle KXD when I set up the proportion. Now cross multiplying. Here, cross multiplying is going to multiply not numbers but expressions, algebraic expressions. So here I will multiply 32 with x plus 6, and that's going to equal to multiplying the 32 not 36, 32 with x plus 6, and multiplying 36 with x plus 3. So this is going to involve distribution. We'll start by first distributing 32 into the x plus 6, so that's going to be 32x plus 192, and then distributing 36 here with x, that's 36x, and then 36 times 3, that's equal to 108. And now we can solve this equation by putting our letters to the left and our numbers to the right. So I am going to 32 move this to this side, which is going to be negative 36x. Move this to this side, what makes it negative 192. plus 108. So this is negative 4x, and negative 192 minus 108, that's equal to negative 84. Dividing by negative 4, that's going to give us a total of 21. So the value of x is equal to 21. And again, we create this proportion by just simply using the similar statement. Same situation here. Our similar statement indicates that the side MN corresponds to the side QR. The side NP corresponds to the side RP, and the side MP corresponds to the side QP. So in order to figure out the length of PR, this distance right here, so from point P to point R, let me use yellow. So from point P to point R, this one right here, I need to figure out what the value of x is first. So I'm going to set up a proportion to do exactly that. So if I get the proportion, the side NP, which is the x plus 8, if I get this x plus 8 and divide it by its corresponding side, which is highlighted the same color for me, that's going to equal to dividing again any other two corresponding sides. Well, I could divide this side with this side, but since I have no data about that, that's not going to be useful. But if I divide this side by this, that's going to be useful. So if I get the 24, and divide it by 28, and it has to be in that order, since I'm going from the triangle on the left and dividing this by this, I have to do the same thing. Start with this triangle from M and P, and again divide it by the corresponding side on QRP, which again is going to be PQ. So I have to go make sure I keep that in the same order. Now, before cross multiplying, I notice here that this number is reducible. 24 over 28 have a common factor. I can divide both of those numbers by 4. So instead of using these large numbers, I'm noticing that they have a common factor of 4. So I'm going to reduce this number and use a smaller fraction for that value there. So x plus 8 is going to equal to 3x minus 9. And dividing 24 by 4, that's equal to 6. Dividing 28 by 4, that's equal to 7. And look how much nicer it is to use those numbers there. So cross multiplying, we would multiply 7 with x plus 8, and that's going to equal to multiplying 6 with 3x minus 9. And it doesn't matter where you put the two sides. If I move this, if I put this on the left side and this on the right side, like if I put them in the opposite order, it doesn't matter. I still get the same solution. So when you cross multiply, it doesn't matter which you multiply first. So here, distributing, we're going to end up with 7x plus 56. This is 18x minus 54. And then again, our letters to the left, numbers to the right. So we end up with 7x minus 18 and negative 56 minus 54. And this one, again, I cannot forget the x on that one. This adds up on the right side. That's going to add up to a negative 110. And on the right, that adds up to negative 11. So negative 11x. And dividing, that's going to give us 10. So the value of x is equal to 10. But again, we are interested in not just finding the value of x, we are interested in figuring out the value of PR. This is what we're looking for. And since PR is 3x minus 9, we can now figure it out by replacing the x with our value of 10, which is equal to 30 minus 9, which is going to equal to 21. So this is the answer that we are interested in calculating. So PR has a distance of 21 units. Let's look at a different example here. Here, again, the two objects, the two triangles, are embedded within each other. So we see that this triangle, P and V, so P and V, which is this one right here, is embedded into this larger triangle, BRG, BR to G. But again, the similarity statement works the exact same way. So if I look at the distance from B to N, this side, B to N, that's going to correspond to the distance from B to R. So that's this entire distance right here. And similarly, the distance from N to R, N to V, this one right here, that corresponds to this distance from R to G, which is this side right here. And the distance from N to V, which is this distance right there, that corresponds to the distance from B to G. So all the way over here to B, all the way to this distance right there to G. And let's see what information they tell us right here. Well, they tell us here that the distance from B to R, so B to R, so this entire length right there is 4x plus 7. And they also give us the information that the distance from B to G, the distance from B all the way to G, this distance right here, this long one right there in orange. Let me get an orange pen. Is that orange? Yeah, it's close enough. That right there, that distance is 18. So this entire distance right here is 18. So B to G is equal to 18. So we're going to figure out the value of x by, again, creating a proportion. So if I get this side of 12, this side right here of 12, that corresponds to this long side, which is 4x plus 7. And that's going to equal, again, to dividing any other two corresponding sides. So I could divide this side by this, but that's not going to be helpful because I don't know how long this side is. I might know the length of N to V, that's 10, but I don't know the length of that one, so that doesn't help me set up a proportion. But I do know, again, that the other two corresponding sides, BV, corresponds to this one right here. And again, I want to go from the triangle on the left to the triangle on the right. So the inner triangle to the outer triangle. So I'm going to divide the 8 by its corresponding side of 18. And again, just like before, instead of using these big numbers at 8 and 18, which aren't really that big, but I do see that they do have a common factor of 2. So if I divide both numbers by 2, I can reduce that fraction and write it as 4 over 9. And isn't that more pleasant to work with? So we end up cross multiplying. So we multiply 4 with 4x plus 7. And instead of multiplying 18, we're going to multiply 9 with 12, which is equal to a total of 108. So I just multiplied that instead of writing it over. Here I didn't want to write this and multiply that immediately. I want to set this up so you see what that looks like, and to remind you that we are distributing. So this is 16x plus 28 is equal to 108. So subtracting the 28 from both sides, moving the 28 to the other side, making it negative 28, 16x is going to equal to a total of 80, and dividing that 80 by 16, that's going to give us an answer of 5. So the value of x is equal to 5. And finally, just one last one. These shapes, again, these polygons don't have to be just triangles. They work, again, with any polygon. So as long as we have a similarity statement, or again indicated corresponding angles, we can figure out the corresponding sides and set up a proportion. So here, by the similarity statement, we are told that KL corresponds to PQ. So K to L corresponds to P to Q. LM corresponds to QR. MN corresponds to RS. And then finally, the first and last letter, KN, corresponds to PS. So if I divide the corresponding sides, 4x plus 4 with 48, that's going to equal to dividing any other set of corresponding sides, particularly this one with this, 7x minus 9 over 60. Now here I don't have the fortune of having a set of fraction. I could do something, but I'm not. I'm just going to use the numbers the way they are. But I could see that these two numbers do have a common factor of 6, and I could divide those by 6, but I'll just leave it the way it is and just use these numbers. All right, so I'm going to set this up, and there's going to be 60 times 4x plus 4 and 48 times 7x minus 9. So multiplying by 60, that's going to equal to 240x plus 240. 48 times 7, that's equal to 336x. And then 48 times 9 is equal to, what does that equal to? 972. 432. So minus 432. Now by putting the letters to the left and my numbers to the right, I have 240x minus 336x negative 240 minus 432. And you see I probably should have divided and simplified these numbers and reduced those numbers, but we're too into it now to do anything about that now. So let's see, we have 240, we're going to subtract 336, that's equal to negative 96x. We have negative 240, and we're going to subtract 432, and that's equal to negative 672. Divide that by the negative 96, and we get that the value of x is equal to 7. So there's our answer. And that concludes, again, the examples, the last example on using, again, using proportions to figure out the length, or to figure out the equation in this situation, figure out the value of x by using a proportion and using, again, the similarity statement. So it's all within the similarity statement to set up the proportion. Again, thank you again for watching. But if you do have any questions, do not hesitate to send me a message on Remind or email. And again, I appreciate you watching this, and I hope you have a great day. Goodbye.